Thanks. Hi, I'm Radek. I'm a developer advocate at Ceramic, and what I want to talk about is about data composability and how it enables you to build better and faster and cheaper as well, and how Ceramic enables that, helps you with that, and gives you the tools for that. So this is the title of the talk. It's like it has a lot of fancy words, like a composable graph database built for Web3 app developers. So that's what ComposeDB is. I'll focus on each and every part of that if that is not clear. The composable part, the graph database part, and how that helps app developers. So currently, what's the journey of the end user like in Web 2? If I go to Twitter, I need to, if I don't have an account right now, I need to sign up. I need to give my name, I need to give my email, birthday, location, whatever else that is required. And then once I'm signed up, I have some ways to customize my experience, like site preferences, showing some posts, blocking some people, choosing other settings. And once I start using the app, like the social app, then I have my social graph. Like I'm adding friends, I'm following friends, I'm blocking people that I don't want to see anything from, and so on. So that's when I came to Twitter. When I come to Facebook then, it's exactly the same. So my purpose is more or less the same. I want to be able to log in. I want to be able to follow my friends or follow people I'm interested in, blog them and so on. But right now I need to go and do everything from the beginning. I need to sign up. I need to give all my data. I need to start following people. And so I need, in order to start getting value from that, I need to repeat the whole process again, as if like nothing that I've done before exists. So that's the journey of the current user in Web 2. So where does data composability comes in? Data composability comes in that an app developer can create a model of a certain piece of data. So I can create a model for a basic profile. And then I set the fields in the basic profile. It could be the name, it could be the birthday, location, email, whatever else. And then I start using that model in my app. And I set up like multiple fields there, some that I use, some I might not use at the moment. And if I do a good enough job of creating a, for example, profile model, I make it available and everybody can then use the same model as I'm using and have access to that data that I have, like those basic profiles. So that's the composability. So if I am a new app developer and I want to like jumpstart my social app, but I don't have any users yet, or the users that potentially I can have don't have any social graph on that social app yet, then I can use those models, like the model for a profile, the model for example, posts. So I can even like take all my, as a user, I can take all my posts from a previous social app to my new social app, and it's already there. I can take all my followers, and suddenly when I'm coming to a new social app, I already have activity, I already have value, and I already want to use it rather than start building everything up. So this is how the data model looks like. I set up the model, and one of the fields in the model is the URL to schema. And schema is what I described, that all these fields that can potentially be there, like username or email name, location, and so on. And then with Ceramic, with ComposeDB, you can interact with that model by creating, reading, updating all the data, and multiple apps can do that. Multiple apps can access, multiple apps can add to it, edit, and so on, based on the permissions that I'm setting up. So that's the composability part of the model. And what are the use cases, and why does it matter? So the core components of the sovereign data that I've been talking about is mainly, and this is the main use case, at least right now, and it's getting more and more steam, is identity. So there are two parts of trust in Web3. So first of all, I, as a user, need to trust like the DApp or the smart contract that it's not going to scam me, or that this is a specific smart contract that I'm looking for and not some scam smart contract that is trying to look like a genuine one. But also from the other side, I, as a developer, as an DApp owner, I need to trust that the user that is connecting is actually a user. It's not a bot, it's not a like airdrop farmer or whatever else. I need to be able to verify, okay, so this is the real user, this is his like identity and reputation, these are the actions that he took over the last like years, and each of those actions like build up their profile, so the actions are over time, interacted with that specific smart contract, did that action on a different app, and so on. So basically, the longer you use, the more you build up the reputation, and then the app can trust that this is the real user. So, and it's more and more important right now, because everything is in all the different parts, but a lot of it is public. It can be aggregated, and it can build up your reputation. So that's one of the use cases. Other use cases could be a public data graph. So basically, all that, like the model and everything else that I described, everything is public and can be accessible by different apps. That's the whole idea of it. There is a way to also have some fields like encrypted, and then it's useful on, it's visible to everybody anyway, but it's still only useful then only to your app, for example. But that's not the main use case. The main use case is that everything is public, accessible to everybody, so that's the part of data that you want to expose, that the one that can be shareable and benefits from sharing. So that's the public data graph that comes in. Open source data models, like I said, if I create a good data model for some specific item, idea, like a basic profile or like social media post, it can have pictures, it can have videos, it can have text, it can have many different things. If I do a good job at creating that, it can be like a basis of a shareable data model that then everybody will start using. And the composability comes in, that everybody agrees that, yeah, this is a good structure, this is a good model, let's reuse that, and let's have access to all the data that other dApps are already using. And that's, yeah, cross-app data as well. And social infrastructure, it's already what I discussed, that you can basically have already a done-for-you social app when you come to a new service. And you reuse everything that you have created. You reuse your social graph, your followers, and people you blocked, and so on. So key components of how this works, how Ceramic and ComposeDB make it easier for you and make it possible for you. So the first is the underlying infrastructure, like level 0 is Ceramic. Ceramic is a protocol that handles all this. It's currently on IPFS, but it doesn't have to be. It's possible that in the future, the underlying layer can be swapped. Right now, it's working on IPFS, but that's abstracted, and that's layer 0. Then layer 1 it's like the ceramic interface, which is ComposeDB. You use it like a database that you use in Web 2. You set the queries, you get the data back, you update the queries and so on. But the question is that the database is proprietary, and the database, nobody has visibility other than you into the database. So everybody needs to trust that. With ComposeDB, you work with it as a database, but it's public, but it also is as fast as using the database, and it also has the benefits of being like data on blockchain, because I didn't mention it yet, but the whole idea also that it is possible and it makes sense is the verifiability. So all the data is verifiable, provable. So it basically, you get all the benefits of having the data on chain, like on Ethereum, for example, without all the cons of it. You don't pay the whole cost for it. It's very cheap. It's fast. So you have the benefits that it's on chain, it's verifiable, but you don't pay for it, and you get it fast. So that's the value proposition of ComposeDB. The way it's being done, that all the data that it's in Ceramic, periodically it's hashed, all its data with Merkle trees, and then the hash is created for that specific piece of data, and then it's anchored. There's a CIS, Ceramic Anchor Service. It's anchored to Ethereum, and these hashes, periodic hashes, are on Ethereum, are immutable, and this is what lets you verify that the data you have and the data you can read and verify that it's from this specific user, it wasn't tampered with, and like I said, all the benefits of having this data on chain without the costs. So this is how it works. So API hosting, it's like Ceramic nodes that everybody can run, or clone another Ceramic node, for example, with that specific model and that specific data that you have from somewhere else. Event storage, it's the API, the Ceramic words as like data streams, like for example, Kafka for blockchain. You can view it like that. Event ordering, indexing. So this is what I said about like anchoring into Ethereum. So it's all verifiable. And then networking, you have the Ceramic nodes that speak to each other, that clone that data that you need, and how you query the data from those nodes for your dApp. I covered most of that already, how it's similar and different to writing to blockchain rather than using Ceramic. Cheaper, more scalable. The goal is it's much faster. It's almost like Web 2, like databases right now. The goal is to have the performance to be as close to reading and writing to your database, like cloud database right now, as possible. Friendlier developer APIs, so it all works on Graph API. So if you are familiar with Graph, you already can use Ceramic, like with small differences. With GraphQL, you write your queries, you get all the data, you update all the data with Graph APIs, GraphQL APIs. So you use the tools that you're already familiar with. And it's also more powerful compared to writing to blockchain, more powerful identity and like the building process. It uses DADs, so you can use any blockchain wallet. You're not tied to any blockchain or anything else. You just confirm your identity, sign your operations, and then you don't need to sign everything, every transaction, or every like 15 minutes. It can persist, and it's by using the DAD models. And also, you can abstract it to use any crypto wallet, so you are not tied to any blockchain. The networks right now that Ceramic provides, the first one, like at the bottom is in memory. It works on your local computer. It's just for development. It doesn't anchor to Ethereum. Then dev is similar to in memory. Clay testnet is what works currently on using Ethereum testnet, so you can reuse the data models that other people built. You can use that anchoring to Ethereum testnet, so you can kind of like work on mainnet without paying the fees of mainnet. And then mainnet, when you go into production, is when you use the mainnet, and then you start using the anchoring to Ethereum and verifiable data. Right now, Ceramic takes care of all of that. You don't pay for anchoring. We pay for anchoring. In the future, the goal is to have it decentralized, and then the cost may be split. Right now, we take that away from you, from developers, from builders, and we take that cost, so you don't need to think about that. This we mainly covered as well. The main use case is decentralized identity, social networks, DAO tools. DAOs is a very good use case because there's a lot of data. All of that is public. There's a huge need for trust and verification of users. So it plays really great into Ceramic strengths. And information graphs, a lot of like science industry uses Ceramic for their research data, for knowledge graphs. So when creating different data or like training models, putting it on chain, you can reuse what others have created before. You can add to it, so you build the models on top of what others did, and then also benefit from that. And some of the current apps that are using Ceramic and ComposeDB is Gitcoin, Lit Protocol, Disco, and so on. And now this was more of a why, and this is now very quickly, we have a few minutes, this is how. So this is technicality. So this is how you set up the data model. So this is GraphQL. This is the basic profile data model. You have the name, you set up all the rules. Is it required? Is it not required? What are the limitations, minimum length, maximum length, so nothing new. And this is how you set up the models. And then you can set relations between the models. So for example, you can only use if you want the profile model, but everything else you build yourself. Or you can build a profile model and use like the posts model, like for social posts, and have access to that as well. And then you can also use the follower model, that you can take all the social graph from other places, but for everything else you can build your own models. So that's the composability. You take what you want and what you need, and for everything else, if it's custom or if you don't want to share it, you build your own models, and you can, for example, not make it public or not make it shareable. And this is the example of that. So basic profile, you reuse that model. So this is at the top, this is the address of the currently existing model, but you create your posts model yourself. So that's how you compose that data. So you get all the profiles, but the posts you define yourself. And this is how you read the data. So this is GraphQL. You query that, you get the data very fast. And you query, advanced query, mutations. This is how you create content. So this should be familiar for GraphQL. And then, this to show you, I don't know if you can see that. Yeah, more or less. So basically, you can do a lot of. So it's kind of like your own database. You query the data. You combine multiple different conditions. I think this is like 4 or 5 conditions combined. You can filter. You can sort the output and so on. So basically, kind of like SQL even. You get all the data, but with all the benefits of having your data on chain. And these are the resources. Ceramic.network is where you can find more about it. ComposeDB, docs and guides, if you want to start playing with it. When you start creating a when you start setting up your environment, you are asked if you want to build a sample social app to start playing with, and that's a good like playground for to see what is possible and how to interact with the data. And if you don't want to host your own node, you can go to hirenodes.io and then host it at a third party. This is our partner. And scan S3 XYZ. This is a repository of currently existing models. So you can have a look. There's a basic profile model. There's like a thread model for social apps or like forums and so on. And there are many different models there that you can reuse or at least get some inspiration from that. And that's about it. That's Ceramic and that's ComposeDB. Thank you.
Great. Thank you very much. I think anybody has any questions? Yes.
So building data first, what would be the road to share different parts of the graph with different apps?
So like I said, so there are already defined models. So if you go to the last link here, scan S3 XYZ, there are already different models there defined. You can have a look at them. You can have a look at the schema of the structure if the model that you want to use. And if you do, then you can also choose to pull in all the data that is already in that model, or you can maybe just use that model yourself and start building your data yourself. But yeah, the idea is you enable HDS, so that's historical data service, I think. So that's an option for you to enable or not, and if you enable that, then you pull all the data that all the other users of this specific model have created, and you have immediately access to that.
Yes.
You had mentioned that data is stored on IPFS. Is there a roadmap to put it on chain, or what is your eventual goal?
The roadmap, there is an idea to potentially swap that from IPFS to potentially a different solution, not blockchain, because then it would invalidate most of the benefits, even an L2 or L3. But we're working and considering like our own like solution and protocol built specifically for speed, for access of data, with all the same benefits of IPFS and without the drawbacks of it.
Any further questions? Anybody? Oh, yeah.
Is your data ACID compliant? Like, are all your transactions ACID compliant?
Sorry, I didn't.
Are your transactions ACID compliant? Like, is it sequenced or guaranteed sequenced?
You have the timestamps. Yeah, you have the timestamps. The timestamps are verifiable, so you can verify the time and the user and the fact that it happened. So those three things are all then hashed and then anchored to Ethereum, so you can verify all those three things, including timestamp, yeah.
Great. Anybody? Okay. So if there's no further questions, thank you very much for being here. It was quite insightful. Thank you. Give it up for Radek, please.